Yeah, so about the next half hour or so, we'll spend time talking about the experience we had in using AI for detecting TB cases in Nigeria. So I will skip the introductory slides to my company, but we have 4 service delivery platforms. The footprint mostly in Nigeria, National Primary Electronic Health Records, health insurance system, our AI-based disease surveillance system, and a mobile health worker training platform. So let's talk about this. Where this came from was when, how did people know Ebola was happening? People died. When enough people died, attention was called to a local area. Methanol poisoning, same thing. Enough people died, attention was called. And so that's where the thought started. Well, what if we could find ways to pick data from the system, assemble the data, and inform an outbreak before it happens? So we haven't done that before it happens. But we're in the intermediate system now, which is where we can inform what is happening and direct people to the places where it is happening using data that illuminates what is not possible with human assessment. So we have an early warning disease surveillance system, uses data from across the ecosystem. Let me just use this schema to illustrate how it works. And so permit me for getting away from the podium. I'm not a podium guy. But we have our data input platforms. There's cloud processing, and there's 3 outputs that I'm going to talk about in the next few minutes. So what are the data input alternatives? In terms of data input, we're really agnostic. All right, as a company, we've been agnostic to platforms because we want to assemble the right solution. So when we put this together, we put this in a data input agnostic way so that we could interact with any incoming data platform, so that we would take that data, and currently we're integrating with EMR systems in HIV. We're integrating with our primary healthcare data collection platform. We've integrated with DHIS2. So it's really any source of data that comes in, because that's really what the system is not developed enough that you can rely on fully developed digital systems. And so what applications have we used this for? So remember, what I've said was we have the data input, we have the cloud processing via AI, and we have the outputs. So what I do want to talk about is I want to talk about the outputs in the context of the applications that we have done. And the applications that we have is TB surveillance and case detection. Happy to announce that we are the national TB surveillance platform for Nigeria with the Nigeria TB leprosy control program. We've done HIV surveillance, we have a malaria prevention concept, a vaccine campaign management concept, and so on. So let's talk about the application. I'm going to just talk about 1 or 2 biases or pet peeves that I have as I talk about this. But this case detection highlights the work that we started doing with the KNCV-TB Foundation under the USA TB Loan Program that was then scaled up by the Nigeria TB Program. So in this program, for data input, we have a community screening application that we built for the Nigeria TB Program. And so this is a smart offline system that's put out in the hands of community TB screeners. The data comes in, they capture the data, and they upload it. And so we have then, and so we've talked about, if you remember that schema, We talked about the input, so let's talk about the algorithm. And so we have positivity alerts. And these positivity alerts notify program managers of where the outbreaks are, right? And it flags for words, right? So in the Nigerian system, you have the federal, state, local government areas, and wards. So the wards are sort of the most micro level of governance. And so that's the level at which we notify the TB program officers that these are the places where you're most likely to find TB cases. And so we flag those wards, and by directing the attention to those wards, the screening and interventional resources are focused on those wards. And at the core of our predictive algorithm is statistical models, right? And obviously we can't go too much into the algorithm, right? Because that's kind of our little secret. But it's just based on very complicated, very sophisticated analysis that I didn't do. My data scientists did. I'm not smart enough to figure this out. But trust me, it works. And a lot of the data, the algorithm was validated against 2 years historical data. And then once set, we then put that predictive algorithm into incoming data. So data's coming in daily from CompTB, running it against the algorithm, and then generating those outputs. So how does this work in practice, right? So every day, the data is collected, comes in, the system runs the analysis, right? We have the hotspot heat mapping and the positivity alerts, and then the positivity alerts then trigger the actions, which is TB community screening. So let's talk about our first output, which is the positivity alerts. And this is one of my biggest pet peeves with people like us that sit in this room and in this forum. I'm going to show you a dashboard just so that I can be, I can look fat, I can look smart and fancy. But those dashboards are almost useless. Right? I defy you to tell me which local program officer relies on the dashboard for decision making consistently and continuously over time. In our case, we transitioned from one platform to another. Our dashboard was down for 6 weeks. Not one person complained. What you're seeing here is our bi-weekly alerts. This is what they act on, right? We missed one and all hell broke loose. Why is that? We all know that there's a very rich body of science on push versus pull technology, right? Once upon a time, we were relying on having to log in to check our emails until BlackBerry came and pushed our messages to us. Right? So for us that rely on pull, you're probably not going to pull your relevant stuff. And this is busy smart guys until the end of the day today. But I bet you those WhatsApp push messages are coming by the minute, and the first thing you guys are going to do at the next break is go check your push messages. You're going to go into the dashboards. And so that I'm sorry, but that's one of my pet peeves, is that we focus too much on dashboards. But let's focus on what people need to act on. And so this email here reads, EWOS has identified potential TB hotspots in the wards listed below. State, Taraba, LGA, Flamingo, Ward, Sentali. You know what these guys do? They get this email every 2 Monday mornings. They mobilize their people to go to these communities. They go there and they find the cases. Nobody looks at the dashboards. So, one of the things that I would like to contribute to this community of practice, deliver actionable messages in forms and media that are actionable. I'll show you, this is our dashboard. Hey, it's fancy. This is, real time. This is heat map of TB hotspots in Nigeria today. All my clients talk about this system being a TB hotspot heat mapping system. I say, guys, it's not about the TB hotspotting, it's about the alerts. That's what inspires the action. So this is the first. This is the first output. Is we deliver the positivity alerts, and this is what the TB program officers at the state, local government area levels. This is what they take, they mobilize, and they act on it. The second thing I talked about, hotspot heat maps. That's great for the people that rely on this for their monthly planning. They look at this and they say, this is where we need to deploy, generate resources for. I showed you our heat map. That's the third one. This is probably the least useful output. As a matter of fact, we can do everything that we're doing without this BI portal. The people that rely on this, that are supposed to rely on this BI portal, they want information, they send my staff email. Oh, I need this information, and we get it to them. We've told them more often than I care to remember that this information, exists on the portal. And okay, well, just send it to me anyway. So that's the third output. So these are a few actions, right? So in this case, this was from 2023. We sent out alarms to these places. They went out and carried out activities and actually found cases. To find 12 TB cases in a ward that's probably, population is probably 500, that you weren't aware that there was TB in that community is a big deal. So these are just, some action cases. And in the first year of the program, after the first year of the program, we were so impressed by just the anecdotal evidence of people going out into the field, finding TB cases, that we thought, let's study this, right? And so we studied the data and we did a journal, a publication in the GMIR publications. The title is Identifying Hotspots of Tuberculosis in Nigeria Using eWars. Retrospective analysis of implications for active case finding interventions. The two sets of numbers I want to point out to you, I want to highlight to you. The number needed to screen to diagnose a TB case was 146 per 10,000 in our hotspot areas versus 193 in the non-hotspot areas. That is a 25% reduction. Now think about any program that on one interventional aspect you can achieve a 25% reduction. Similarly, right, so this was just comparing hotspot versus non-hotspots, and we also looked at longitudinally before eWars was started, right, the number of presumptive cases needed to diagnose a TB case was 14.047 per 10,000. And after eWars was introduced, it was about 10.255, again, approximately 23%. So we published this. I have 15 peer-reviewed publications. This was the most rigorous. I was like, hey guys, just publish this thing. In the interest of time, actually, let me just, I think I'm doing quite well on time. So I'll spend a few minutes on our HIV case, use case. So I'm going to go off script. The basic tenets are the same. The construct is the same. But we took a very different approach in HIV, right? First, we just did the plain vanilla stuff. Let's figure out where we're seeing a surge, and let's take that surge and put it on heat maps, and send out alerts and direct people, right? And so that's kind of plain vanilla, and that was effective, very effective. But we did something else that was more fun, which is kind of where the AI comes in, right? We came in and said, well, of your populations, there's, in that program, which was done with the Center for Integrated Health Programs, the key metric that they were working to reduce as much as possible was something called interruptions in treatment in their antiretroviral therapy regimen. And so what we did was look into the patient's history. We developed algorithms that said if the patient's profile exhibits these characteristics, then it is highly likely that this patient will default from either showing up for their sample collection or taking their medication. And so what we did was we would flag these guys, right? Would flag those guys, would provide the line list and say, these are the people, right, that you need to focus on. And then what we then did was we took these guys and focused them, right, the centers where there's, focus them in areas of regional concentration. So if there's 100 people at risk in location A, you're probably better off focusing your interventional resources on location A than location B, where there's just probably 10 people, right? And so we take those people, throw them into those concentrations, put those on heat maps, and we send out alerts. So we said, he was an identified potential IIT hotspots in the following area, and we listed. And again, the program people, they sit, they wait for this. Every 2 weeks, they get it, they mobilize, they go out to the field, and they take action. This is numbers that they reported. We're trying to get these guys to work with me to publish this because this is really strong, right? But this program is in its third year right now. They just, as of last week, just announced that they were extending it to next year. So, EWAS is common sense, right? In TB detection, there were 3 phases. I'm not a TB expert, I'm not an epidemiologist, but we had 3 phases. Phase 1 was where we went like this, and where are the cases, and we'd go, and we'd find nothing. And then really smart people came up with data science. And then, did surveys based on historical data and found out where the concentrations were. Then they started going to those places. But what that approach missed was the dynamic changes month to month, season to season, year to year, especially, as you have things like climate change. If you are looking at, TB patterns in the last 3 months, in the last, actually maybe 2 weeks in southeastern United States, I'm sure the data will be all over the place, right? But if you had a model like this, you'd capture that because you're capturing those dynamic actions. So it's all common sense that using some type of intelligence will be better than using no intelligence. And so then comes the next part, which is introducing machine learning elements. So we get new data, we refine the models. So in the next iteration, it gets better, and it gets better, and it gets better. So, there's a lot of stuff here. I don't need to go into all of this, but we're just going to go deeper down the AI path. Because what we're doing is really, I'm going to just basically admit to all of us, because we're really smart people and we all know, probably a couple of people in this room know more about AI than myself, right? And so probably you'd be like, what are you talking about? But we are not predicting TB occurrence. We're identifying where it's happening. In the next iteration, we're going to predict TB occurrence, right? Because the variables that drive occurrence are known. We're going to be able to predict malaria occurrence. We're going to be able to predict, COVID occurrence. And using these techniques, we can, we can then tell you specifically where those. I remember about 10 years ago being at the Brookings Institute, and this guy showed me this model that if there's an infectious disease, and this was just amazing, because I thought back, I reflected post-COVID, if there was an infectious disease outbreak and it came into California, you'd first see it light up on the west coast of the US. The next place it would show up would be New York, and the entire East Coast would light up. And then you go back to the West Coast, light up the entire West Coast, and then you start seeing pockets. And that's almost exactly what happened with COVID. So that's the area that we're going to go. We're going to start to put in ChatGPT so that people can better contextualize the information that's coming back at them. And we, the gentleman that spoke to me before just spoke. Talked about chatbots and natural language processing. So that's the direction that we're going to go, to just make this more usable and more relevant. And hopefully, I'll be a happy man when dashboards die. So, thanks. We have a couple of minutes, I think. How long do we have?
You still have 7 minutes.
7. All right, cool. So we can take questions. Yes.
You go back to your slide 12.
I don't know which one is 12, but. Where you count? Okay, is that 12?
Yeah.
Yeah.
So to me, you're saying that's an action report, but to me it looks like a dashboard, right? Because it's just telling you this date, this LGA, this ward, this count, this yield. It's not actually, and you send, and these raise alerts. Does somebody else have to figure out what to do?
No. So
there's
three of you here, right? You're from Jalingo, right? And you're from Wukari, and you're from Gasol. The three of you get this email. What do? You take this line and say, well, I have to go to this too. I'm from Jalingo LG, I run it. I have to go to this too. And then you take Wukari, and that's where you mobilize your team. You call your guys. You're like, okay, hey, 1, 2, 3, let's go. The same thing, you focus on yours.
So what it's doing is mobilizing the case finding.
Absolutely.
Okay.
And the earlier version of this, we had like probably 250 emails going out. We're like, guys, because what we're doing, we're sending the specific people action emails. And then some email filters picked us up as spam email. They were generating spam. And they started blocking our email. So we said, let's aggregate, right? And then send to people. And so the people know that if you're from Bali, this is the only line that's relevant to you. But your point's fair. I mean, given everything I've said.
It's like a dashboard.
To all of us, it's a dashboard.
Yeah.
But to this guy, he just sees, I need to go. Remember, if you look at Jalingo, for example, Jalingo probably has, 20 local government areas and probably 250 wards. Where do they go? We've made that job easier for them by saying, in this period, just go to 1, 2, 3 wards, and you'll be fine.
Great.
Thank you. Please.
Yeah, thanks for the presentation, and glad to see you're looking at catching adherence fallout in the future. Two questions. So the first, so is this a like closed loop where feedback on where they don't find patients kind of gets fed back into the model for improvement? And then maybe this is what you're doing in the future, but you talked about a lot of the data that comes from the data, like the screening population into the model, but is also the risk factors of the population taken into account as well?
Yes, so the first question, we're doing the converse. So if you don't find cases, there's nothing to feed back, right? But when we find cases, what we do is we have exclusion criteria. So that, because if you go here, you screen, you find cases, and then you generate alerts. So you go back and screen again, you find more cases. And so what we have is we have exclusion criteria. And then ultimately, all that data is coming back, and periodically we revisit the algorithms and fine tune them. And I think that kind of gets to your second question. Did it?
Yeah, essentially just, you're not just taking the data from that case reports, but also the population level data.
Right, okay, yeah. So to get to that, right? So the good thing and the really powerful thing, I'm not a data scientist, so please somebody, if you're a data scientist, correct me. But the powerful thing by getting in real-time cases from real communities is that you're already almost implicitly addressing for all of the variables, adjacency, concentration, travel patterns, you name it, you're addressing all of those by taking it, because the best data is the positivity rates, because the positivity rates address all of the issues that result in the positivity, I think. Sorry.
I had a number of questions. The first one was already addressed.
Please.
So my question is, so based on this, so how was this calculated? Basically, how did you compare this patient count? Was it verified through other processes, microscopy or others? How is it confirmed that there was this presumptive?
So these presumptives are real. So we found that in the last, so we had the algorithm is very sophisticated, but roughly translates, and the secret here is when we've tried to explain this to the people that are not so sophisticated, we just say, listen, if you have a 10% positivity rate in a word, you've met the threshold, we flag it. And so the algorithm roughly translates to 10% positivity. And so these are real numbers, right? Number of presumptive patient counts, you're above 10%, so we flag you.
I get it, but normally when there is a new methodology that comes to the market, whatever we speak about, AI is one of them.
Yeah.
You need to compare to a gold standard or to something else to verify the assessment and make the estimation of how your presumptive case and AI tool can evolve over time, right?
So I will, if you're happy to, I will send you the JMIR report, right? So the Journal of Medical, that research report dealt with, because we did that in collaboration with the University of Texas, Southwestern Medical School, and the medical school and the computer sciences. So they ran some really sophisticated analysis. I'm happy to send that to you.
Yeah, my pleasure.
Right, so I'll just drop my card so that we can do that. Sorry, I think there was one more question in the back, and then we'll wrap.
Last question.
Just a quick question, maybe you covered it. I mean, this is great in that you're using this data in a very practical way around program improvement, but linking, there's a gap that I don't quite understand, is that what were the workflows that this is replacing? They're not using dashboards. Dashboards, were they intended for the case management, or were they intended for your donor or government or somebody to see a pretty heat map? So what were the workflows that replaced?
Every month they have planning meetings, And in those planning meetings, they use whatever other mechanisms to decide where to go, canvas for cases. I don't know what those were. So I think I said in phase one, it was like, right? In phase two, it was like, well, based on surveys. And now, what we're doing is we're giving them specific targets. So the workflows we're replacing are those monthly meetings where they would then decide where to mobilize their case finding teams to go to. So now we're just giving them information. We're just saying, go here. It's like, you went back to your hotel, you go into Google Maps, it scans everything and says, well, there's traffic on this way, you go this way.
And so has there been pushback from this change in workflows? I mean, you were paying seating fees and meetings monthly to get everybody together, now they don't need to.
Well, they do, they still have those meetings.
Okay.
But those meetings are informed by this.
Okay.
So the guys that rather than sit monthly, I say, where do we go? And you come up with, well, here's what I think, and you have a big fight and debate, right? And those monthly meetings is like, okay, so EWOS says, this is all terrible. I say, these are the 10 places we go to. Do we all agree? Yes, we agree. We don't have enough resources, so maybe we go to the top 5 places, right? This has the highest number of presumptive, so those are the types of conversations that happen now. So,
No, okay. I mean, it's quite interesting because there are a couple of questions to ask on how this will go.
So thank you very much, everyone, for your time.